Hi, this is the second video for the concept of infinite limits. In the previous video one about infinite limits, I explained it intuitively, means that the actual meaning of infinite limits, right? So in this video, I'm going to tell you how to evaluate the infinite limits in a very fast way, right? Without consider the actual meaning of the limits here. Alright, for example, you have this type of limits. You know that 1 plus is a number very near to 1, right? Very near to 1, but it's from the right. Okay, from the right. So means you 1 from the right here means that you're going from the right, but not reaching 1. It's not reaching 1, it's approaching. Approaching means mendekati. Approach means that it can be 1.001. Right? This is like something like from the right. So from the left is something like from the left 0.9999. If you round off, you're getting 1, right? But it's less than 1. It's not less than 1 means from the left. So now to evaluate this one, if we keep on consider this type of thing 1.001, 0.9999, it some like make us crazy, right? We'll feel like, oh, so stressed, I want to think about this thing, very discrete, right? So if this thing happen, we can think like this way. We can try to think like this way. So the first step is you consider the case here. By doing direct substitute. So you have 1 in your mind, intuitively, innerly, you think that if you substitute 1 here, 3 minus 1 square, you are getting a number 2, right? So 3 minus 1 is 2. So, but when you directly substitute the value of 1 minus 1, you are getting 0. This is the case. You have a case that I teach you in the previous video is 0 over 0, right? This is a case where you need the method of factorization, where in the video I'm talking about you cancelling the common factor, right? So if you have if you have surd, you multiply conjugate, right? That is the technique only applicable for this type of cases. So now for this type of cases, so where there is a number, there is a 0 here. So the answer will be always infinity. Alright? The answer. So the technique here very easy. So it's always infinity. Always infinity. This one also the same. You don't consider the 1 minus or 1 plus. Don't consider. You just directly substitute. 3 minus 1 square, you're getting 2. Right? 1 minus 1, you're getting 0. A number over 0. Okay, that's the answer, infinity. But you have to decide positive or negative. Positive or negative? Positive or negative? Don't know. But I know the answer is infinity if this is the case. So now, alright, let's look at 1 plus here. Right? So as you know that you're putting 1 here, this is a positive number. This is a positive number, right? Because you're putting 1, you substitute 1, you're getting 2. You ganti 1, you dapat 2. 2 mestilah positive. It's a positive number. But this is the one that you must be careful, have to consider. Okay, 1 plus. 1 plus is a number greater than 1. Bigger than 1. 1.1, 2. 1.1, near to 1, okay? If you don't want to think something like this, you just choose a number greater than 1, 2 for example. 2 minus 1. 2 minus 1 is 1. It's a positive number, right? It's a positive number. This one, of course, is a positive. You substitute, getting 2. Positive, you're getting positive infinity. That's all, right? Oh, how about this one? As I know that you substitute 1, you're getting 2, right? It's a positive number. But this one, 1 from the left, is a number to the left of 1. For example, you can choosing 0.9, right? 0.9 is to the left of 1. 0.9 minus 1, a smaller number minus a number less than 1. 0.9 minus 1 is like negative number, right? negative 0.1. So it's a negative number. So you just think positive, negative, then you have negative infinity. That's all. Very easy. Without consider this thing. But if you can consider this thing, you are very matured in mathematics. So this one is to help you in finding the infinite limits, right? So student like this way, but this is a real mathematician. You have to think this way. All right, that's the concept here. So now you're getting positive infinity, you're getting negative infinity. Means that as x approaching 1, you're getting positive infinity, you're getting infinity, you know. You're getting infinity. So means that x equals 1 is a vertical asymptote. Is a vertical asymptote for sure, 100%, because you have already verified that. Okay, means that if you're sketching the graph, if you're sketching this graph here, so this graph may be different. Okay, you haven't sketched, but you know there is a asymptote here. So you know that during 1 there is an asymptote, and from the right is positive infinity. Means that from the right the graph will be going up. You know that it will going infinity very high, right? So as if 1 plus. So 1 minus, as 1 approaching from the left, 1 minus. So they were going negative infinity. The graph, if you draw, it will going negative infinity. I don't draw other part of the graph because this graph may have horizontal asymptote. Horizontal asymptote I may introduce in another video after this. Alright, so now this is an infinite limits. You see that? From the right going positive infinity, from the left going negative infinity. So this one is your vertical asymptote. So this is the concept here. So I give you another 2 more examples. Alright, let's look at how to evaluate this type of limits. Alright, this will be another example of infinite limits. So before you're watching the video, I will always encourage students to consider to evaluate the limits first before you're looking at my solution here, so that you have a process of thinking and you have better understanding, right? This is the way that a mathematician should do, alright? So then you have 1 plus here, you have 1 minus here. So I don't know whether this case is a case of 0 over 0 or a number over 0. So I have to directly substitute first. If I'm getting 0 over 0, it will have a special technique to deal with this problem. You have factorization, you have multiply with conjugates. So now, I don't think so this is the case because you substitute 1. You substitute 1. 1 over 1 minus 1, you're getting 0. This is the case where there is a number over with 0. It's undefined. But for this type of case, I remind again, the answer will be always infinity. Sir, why is it infinity? I have already explained to you in the first video of infinite limits, where I'm writing all the 1.001, 0.001. Okay, so that's the concept. Alright, so now I'm going to teach you the techniques here, right? So you have infinity, but positive or negative, right? Positive or negative. So then we try to think about this. This is always positive. Sir, why this is always positive? Because 1, you directly substitute 1, x will be 1. 1 is definitely positive. To decide whether they are positive or negative, we look at the denominator. But you see the square, right? If you understand mathematics, so you have square here. 1 plus, choose a number greater than 1. But don't too far, don't choose 100. Don't choose 2. You choose, okay, you can choose 2, but don't choose too far. Okay, don't choose 3. You can, the better, the nearer, the better. So you choose 1.1. From the right, 1.1 minus 1. 1.1 minus 1. Positive, right? 0.1. You square, you are still getting a positive number. Positive or positive, you're getting positive infinity. So this one positive, but from the left, you can choosing 0.9, right? So 1 to the right, 1 to the right, 1.1, right? To the left, negative, 0.9. For example, 0.9 minus 1. You are getting negative, right? You're getting negative. But in this case, there is a square. a negative number square, you were getting positive. So you were still getting positive infinity. Now for this case, you see both sides going to positive infinity. So then it's okay. Either one go to infinity. Either one go to infinity. As long as one of the side, one-sided going infinity, then x equals to 1, right? Approaching 1, right, left, means that the 1 is a vertical asymptote. So this is how we judge something is a vertical asymptote. Okay, if you're drawing the graph, so you will have 1 as a asymptote. But for this time, from the right, from the left, from the right, it's going to positive infinity. Positive infinity. Alright, you see, you were going positive infinity. So from the left also, from the left of 1 approaching, it will also going to positive infinity. Means the graph will be approaching this line at positive infinity. Alright, so x equals to 1 is a vertical asymptote. So okay, I will give you one more example. Alright, let's move on with this example. So infinite limits. Alright, again, same thing, you can try first, right? If you understand, you can try first. So the first thing that you're going to evaluate these limits will be you test the value, right? You substitute the value, directly substitute. So you have 3 square minus 1 and 3 square minus 5 times 3 plus 6. I think you were getting 9, right? 9 minus 1, you're getting 8. This one you have 9 plus 6. 9 plus 6, you're getting 15. Minus 15, you're getting 0. Undefined, right? So this is the case. So this is not important. I don't want to know what is the value. Okay, undefined. No, this is I want to verify. Just want to know what is the case, right? Case. So if this is the case of a over 0. So a over 0, the answer for the limits always infinity. That's all. But the problem here is positive or negative. Positive or negative. That's the problem. So now, okay. So as I tell you that, you can straight away write your answer positive or negative infinity for this type of cases here. So for example, you look at here, x squared minus 1, you can rewrite to so x minus 1, x plus 1. Okay, doesn't matter. I don't think so you need a factorization here. So I only factorize the denominator here, right? Denominator, because I know that this one for sure is a positive number. This one for sure is a positive number. Why? You see, 8, right? You substitute 3, 9 minus 1, 8. 8 is a positive number, right? 3 square minus 1 is a positive number. I just need to know what is the sign here when I substitute 3, a number greater than 3 into the denominator here, right? So, so now I can using this one is surely positive, then the denominator you can factorize, it become xx 2 3 negative negative if not mistaken. So x squared negative 2x negative 5x positive 6, right? So now to be positive or negative, you look at this number here, right? This 3 here. You can choosing a number. Okay, for example, 3, right? 3. So if you substitute 3 minus 2, you're getting positive here, right? Positive, positive. So 3 is positive. Because 3 minus 2 is not 0, so okay, we can directly substitute 3 there. But when you're choosing 3, if you directly substitute 3 minus 3, you're getting 0 here, right? So you don't choosing 3, because this is actually more than 3, right? More than 3. A number more than 3, 4, for example, 4. 4 minus 3. 1 is a positive number, right? So 3 minus 2 positive, 3 squared minus 1 8 positive, all is positive, so you're getting positive infinity here. All right, positive infinity here. So and 3 minus here means that from the left, approaching 3 from the left. So I can, okay, I understand this must be positive. 3 square minus 1, you're getting 8 positive. So if you substitute 3 into here, 3 minus 2, you're also getting positive. Okay, but you only consider a number less than 3 minus when you're getting 0, because the substitute you're getting 0 here, right? So it shouldn't be 0. So 3 minus, choose a number less than 3. For example, don't choose 2, as 2 is also one of the asymptote. 2 minus 2 is 0. So I don't choose 2. Less than 3. Less than 3 from the left. So you can choosing 2.9. Right? 2.9. So 2.9 minus 3. Smaller number minus a bigger number. So you're getting negative, right? Positive, 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 negative. You're getting negative infinity. Right? So you go to infinity, negative infinity. So means that 3 minus, 3 plus. So means that x equals to 3 is a vertical asymptote. Right? But is this cases, this function have only one asymptote? My question here is, this special question here is this function only have one vertical asymptote? Is it only 3 is a vertical asymptote? No, there is another asymptote, because as you factorize the denominator, you are getting fx equals to x squared minus 1 over with x minus 2, x minus 3, right? You know that x shouldn't be 3. If x is 3, 3 minus 3, you're getting 0, right? A number divided by 0 cannot undefined. But x also cannot be 2. You have to know that x also cannot be 2. So 2 should be also another vertical asymptote for this function here. This function have 2 vertical asymptotes here. So now I have already proved that for 3, it's go to positive infinity, negative infinity. Now it's you to prove that 2 is an asymptote here. So you do first, then you see how I prove that 2 is also an asymptote. Alright, let's continue proving that 2 is also a asymptote, x equal to 2, because as you know that the denominator should not be 0, as x cannot be 3, right? 3 minus 3, 0, right? And the problem here is when you put 3 up is a number, right? A number. So it means that 3 is an asymptote. 3 is an asymptote, x equal to 3 is an asymptote, because as you substitute the value of 3, you're getting a number up there, but you're getting 0 down there. So x equals to 3 is an asymptote. So just now I have teach you how to verify, right? So now for 2, now it's for 2. So x also cannot be 2, because when you put 2, it was still getting negative, right? Sorry, you're getting 0. So now, okay, let's evaluate. This is the case where a over 0, right? You understand that? Because when you substitute the value of 2 square minus 1, you're getting a number, right? You're getting a 3. It's a number. If you substitute 2, you're getting 0. So now this case, the answer is always infinity. Right? This is the easier way to evaluate. So now, if you choose a number greater than 2, what happened, right? A number greater than 2. For example, just now you know that x squared minus 1 over with x squared minus 5x plus 6. And you have already rewrite this thing as x squared minus 1 over x minus 2, x minus 3, right? So if you directly substitute the value of 2 into the, you are getting positive, right? Getting positive. 2 square minus 1 is positive for 2. But now, you substitute 2 here, right? 2 minus 3. You can substitute 2 here because it's not 0. 2 minus 3, you're getting negative, right? 2 minus 3 is negative number. So it means this one always positive, this one always negative. So this is the one that determines whether positive or negative for this case. So 2 plus a number greater than 2. Don't choose 3 because 3 minus 3 is 0, right? Don't choose 4. 4 is beyond 3, very far away from 2. Okay, so in this case, so 2 from the right, so means that something like 2.1, right? To the left, 1.9. right? To the left. So let's say to the right, 2.1. 2.1 minus 2, positive number, right? Positive number. So positive, positive, positive. Positive times negative, negative infinity here. Alright, so how about now we consider 2 from the right, from the left, from the left. So from the left of 2 is 1.9. Okay, 1.9 minus 2. 1.9 we consider, right? 1.9 minus 2, you're getting a negative number, right? So positive, negative, negative, positive. So finally you got getting positive infinity. This is also that you already proved that when approaching to 2 from the right or from the left, either one going to infinity, then x equals to 2 is also a vertical asymptote, right? It's a vertical asymptote. So how many asymptotes for this graph, for vertical asymptote? So I can say that x equals to 2 and x equals to 3 are the vertical asymptotes of fx, of this function. I have already verified. This is the way I verify. So 2 and 3 are the vertical asymptotes. So okay, if I sketching the graph, I can see that if I sketching a graph, I can see that how the graph goes here. Very easy. Alright, so if I sketching a graph, okay, very fast. So this is for your extra knowledge. Alright, if you love mathematics, you can keep watching this. So 2 plus means you have how many asymptotes? You have 2, you have 3. You have 2, you have 3. Right? Just now, you look back the video just now, when x approaching 3 plus, you are getting positive infinity, right? Getting positive infinity. When 3 minus, refer to the solution just now, so you're getting negative infinity. So 3 plus from the right, you are getting positive infinity. Positive infinity. Going up means positive infinity. The value of y very big. So when 3 minus from the left is negative infinity. So the graph going down, right? Going down. How about when 2 from the right? From the right of 2. From the right of 2, the graph going negative infinity. Negative infinity. So can you see that something happened here, right? It could be have a stationary point here, a turning point here. This is you haven't learned this. It's a very beautiful mathematics, right? Mathematics is very beautiful. So when you understand mathematics, you understand limits and you understand differentiation, the concept of a calculus, you can draw a very beautiful graph. So 2 minus, this one I haven't teach you, alright? So you will learn this in university, alright? So now 3 minus, so it's suspected to have a stationary point, so that they were going this way, right? Going. So now how about 2, the 2 negative, right? From the left, you're getting positive infinity. So means that from the right, you're getting positive infinity, right? Getting positive infinity. So this is the flow of the graph. This is not the actual graph, but the graph is really approaching the 2, the 3 at infinity, right? So this is the vertical asymptotes. So infinite limits, the concept of infinite limits is using to find the vertical asymptotes here. So that's all for the concept of infinite limits.